For assignment 1, I've chosen to create an app that is capable of graphing polynomial as well as exponential functions. When I run my program, a GUI interface appears. We see that in the center of this GUI interface we have a Cartesian plane. On the left top corner I have 4 buttons, each allowing me to input a different kind of function. On the right hand side we have a clear all button, which clears everything that is displayed on the Cartesian plane as well as in this NIST box. This NIST box is used to record every single function that I've inputted in string form. For example, if I were to click input exponential, and if I was to input 2 to the power of x, when I click graph, the graph of this function would appear on the Cartesian plane, and the function in string form would appear in this NIST box. I would like to start by explaining the structure of my written code, and then I would like to trace a few most challenging parts of my code structure. So my written code is structured in blocks, and these blocks are separated by these lines of comments. The first major block I have is my self method, which is run at the beginning of this app. My second block is called miscellaneous blocks. I have here all of the short methods that I use to, let's say, cast inputs into float and etc. My third block is called taking functions. These are all the methods used to create the widgets that you see for user input. My fourth block is called graphing functions. These are all the methods used for turning the user input into mathematical values and then putting them onto the display box, which is the Cartesian plane. And my final block is called graphing derivatives. These are for calculating the derivative of each input function, putting this derivative onto the Cartesian plane. At the end I have one more small block, just for fun. It is called linear integration. It doesn't really calculate the linear integral. Instead, it simply demonstrates the principle of linear integration. And finally, we have the main method here, which is just one line, calling on this app that I wrote. So, I would like to start tracing my program by seeing what happens when the user does this. So when the user clicks on the button input linear, this calls on the method stateSet. But the interesting thing is, whichever button the user clicks on, either linear, exponential, quadratic, or polynomial, the very same method is called upon. But my program distinguishes between these buttons by passing on to the stateSet method a different parameter. In the case when the user clicks on linear, the parameter passed is the string 9. So when I go to my method stateSet, which is defined in my taking functions block, this button ID parameter is set as 9, and so this condition is true, and so we set the following 4 Boolean variables to be true, false, false, false. If the user had clicked the quadratic button, then we would have set the same variables to false, false, true, false. Once these variables have been set, the same method calls upon another method named take. This take method is defined right here. What it does is, first of all, it runs this method defined earlier to destroy all the take widgets. So let's say I already have the quadratic widgets appearing on the screen, the instant I click input linear, these widgets are destroyed. Then the appropriate widgets are created because I know that only button nin state, this boolean variable is true, all the other variables are false, and so this action is taken. The take line method is defined here. At the top of my taking functions block, all it does is it says create a label y equals, then make an entry for the user to input, then a label x plus, then an entry for user input, then a button for graph and a button for graph derivative. Now, I ran into a few challenges when creating the take functions block, because originally when I click input polynomial, let's say, then I don't want to input a polynomial anymore, I want to input a quadratic. The quadratic widgets would overlap the polynomial widgets, and the polynomial widgets wouldn't disappear. And this made it very confusing for the user. So, my solution for this is to create this destroy all take widgets method, which would allow for me to call on when I run this take method, but also to have this state set method, so that only one button can be true at a time. Now, a second issue I had is that once I implemented this change, I noticed that when I start running my program, I had to do this action, clicking on linear, clicking on exponential, then quadratic, then polynomial, in this specific order. And then I can click on any arbitrary button and it would work. Otherwise, when I start the program and I simply click on input quadratic, for example, nothing would happen, and I would get an error here in the console because the input linear widgets have not been created yet. And so when I say destroy all take widgets in my take method, the computer doesn't know what to destroy. And so it would have an error here saying, I don't recognize this widget that you're asking me to destroy. My solution to this is to write a method here called start, which simply creates every single widget that I will ever create in my program and then destroy them simultaneously. This method is called upon at the very beginning of my self method, right here. And so the instance I click run, all the widgets have already been created and then destroyed. And so whichever button I click on, the computer would have no trouble recognizing all of the other widgets that I'm trying to destroy or create. The second challenging part I would like to point out is what happens after the user inputs. So after the user inputs the coefficients for the linear function, he or she has the choice to click the graph button. This button takes us to graphLine method, which is defined in graphing functions block, graphLine. And this function simply takes whatever the user inputs into the two entries, E3 and E4, which correspond to these two entries, and cast them into float using a casting method that I have defined myself, which I will explain later. And then the method stores them into A and B. With this A and B, I can easily calculate the coordinate of any 2 points really on this function, and then make the program create a line that connect these 2 points. And so I have the linear function. I then insert into the function list box, which is the list box on the right of my GUI interface, a string in the form of y equals, then the string form of my slope, then x plus, then the string form of my constant. I would like to quickly explain this useRat method, short for useRational, and this coef to string method, which are two cast methods that I've designed for myself. They are both defined in the miscellaneous box block. The useRat method is very simple. It takes a string that user inputs. Let's say I input 0.5. It takes this string and then it tries to cast it into a float. In this case, 0.5 will have no issue in being cast into a float, and we return the result 0.5 as a float. No problem at all. But if I were to input 1/2, well, the computer would not be able to recognize this as a float, and so we have a value error. And thus, we have to use a different method to cast that into a float. This castFract method I have defined here. It simply finds where the slash occurs in the user input. Then it takes the integer, which is from the beginning of the string until the slash. Then it takes another integer, which is right after the slash until the end of the string. It divides up by down, and here is our resulting float from the user inputted fraction. The coef to string method is also really simple. It takes a float, let's say 2.3. It decides whether this float is an integer or not by checking this condition. If it is an integer, say 2.0 would be changed into the string 2, but 2.3 will stay as the string 2.3. My most challenging part in this program is the polynomial methods. When the user wants to input a polynomial, he or she calls upon the method stateSet with the parameter poly. We then go through the same logic and the computer runs takePoly. takePoly creates a very simple widget, y equals, and then a very long entry in either graph or graph derivative. The very long entry allows the user to input a string, let us say x to the power of 2 plus 2 times x to the power of 5 minus x plus 1. Now, the problem for me was, how could I change this string into something that the computer can use? And so I have created for myself a trilogy of methods. And this trilogy of methods works as follows. The first method, listTermBreaks, takes a string. Let's say this is the user input string, and it highlights the positions where plus or minus signs occur. So in this case, it would be the indices 4 and 6. But for each of these places, we need to remember whether it was a plus sign or a minus sign. So with the 4, we pair a positive one, and with the 6, we pair a negative one to indicate that it's plus sign at index 4 and negative sign at index 6. We then go to our second method, which first calls upon the listTermBreaks. Then it starts from the beginning of the string and goes until the first term break happens, the first plus sign. Then it creates a substring of the original string, and pairs that with the sign indicator.